All right, I'd like to walk you through how to solve the question number 23 from section 4.1. And this is kind of a typical question when we're dealing with permutations or factorials. Okay, how many 5-digit numbers are there that include the digit 5 and exclude the digit 8? So I like to draw these pictures out this way. So we have 1, 2, 3, 4, 5 digits. And so we're going to imagine these as digits. So this, I'm going to put my options, and up here I'm going to put my number of options. Okay? So 5-digit numbers are there that include the digit 5 and exclude the digit 8. It's kind of hard to force a 5 to happen. So what we can think, first of all, let's just walk through. Let's pretend like it doesn't say anything about digit 5, but we don't want an 8 and we need a 5-digit number. So generally it's accepted that this number right here, the first position here, is not a 0. Okay? And the reason for that simply is if a number starts with a 0, like if I said the number 001, well, that's just 1, and that's a 1-digit number. It's not a 3-digit number generally. So same thing here on the 5-digit number. I would not include a 0 at the beginning because that's just weird. So this would be the numbers 1 through 9, whereas this could be 0 through 9. This could be 0 through 9. This could be 0 through 9. And this could be 0 through 9. Okay. I'm going to short form this. So I'm going to say right here, cannot equal 0. Okay. And then we also know that none of these can equal an 8. So this cannot equal 8. This cannot equal 8. This cannot equal 8. This one cannot equal 8. And this one cannot equal 8. So we can think of this as having the first spot could be a 1, a 2, a 3, a 4, a 5, a 6, a 7, and a 9. So there would be 8 options here. And then here, the second digit, we could have a 0, a 1, a 2, a 3, 4, 5, 6, 7, and a 9, which would give me 9 options. And each of these would have 9 options. Okay, but the problem is I haven't done this. I haven't included the digit 5. We need to have a method. So I know that there would be answers here that include a 5, but I don't know for sure that the number 5. So an example of a number that could show up is 23,500. No, sorry, that could show up 423. But that number does not have a 5 in it, so it wouldn't fit into this category. So this right here has a problem. Okay? So my way of doing this, and this is just one way of doing it, there's lots of creativity in this. So my first option is I'm going to make sure that this number right here is a 5. So an example of a number that would do that is 52,351. So I know that number will happen here. If I force a 5 here, I'm going to make these ones 0 through 9, but not an 8. So each of these would be 9 options, 9 options, 9 options, 9 options, etc. So that would give me 9 to the power of 4, which is 6,561. Okay. Now, that gave me every number that begins with a 5, but that didn't give me every option that could be, for example, what about the number 35,241, which has a 5 in the second digit? Okay, so we're going to make sure that happens this time now. So here we're going to come up with the numbers 1 through 9, but it can't equal 0. Oh, we already took care of that. Oh, okay, we won't make it an 8, 0. Can't make it an 8. But we also can't make it a 5 because here on this question, we already came up with every number that began with a 5. So now we don't want to come up with more options that begin with a 5, or else we're double counting. So we take off 3 options off of that. So it leaves us with 7 options here. 1, 2, 3, 4, 6, 7, and 9, which is 7 options. Then here, we're going to force the 5 to be in the second digit. So there's 1 option there. And again, these ones are 0 through 9, but not 8. So that gives me 9 options, 9 options, and 9 options. I'll continue writing this. Okay, so that is 7 times 9 times 9 times 9, which is 5,103. And then we just keep going through this. So now we're going to make this digit a 5. This one's going to be a 1 through 9, and it can't be a 0, 8, or a 5. This one can be a 0 through 9, but it can't be a 5 or an 8 this time, because again, now we're coming up with examples that might be like 23,555 could be one of these options here. So here we have 7 options. Here we have 8 options, I believe. 0, 1, 2, 3, 4, 6, 7, and 9. 8 options. 1 option here, 9, and 9. Again, for the 0 through 9, but not 8. Okay, and what you're going to do every time is you're going to multiply across. And then when you get all of these answers, which there's going to be 1, 2, 3, 4, 5, we're going to force the 5 into this position, and then you're going to force the 5 into the last position. Okay, and what you're going to do is you're going to add down, and these are the number, or sorry, we're going to add down because these are different cases. And they're mutually exclusive. You can never have the 5 in the first digit and the last digit here, given the way we've set this up, because this one will never have a 5 here because we always prevent the 5 from happening. So continue this pattern for the last 2 and see if you can solve this question. And as a bonus question, why don't you see if you can solve the exact same question? Well, let's change it. So let's make it so that it's a 4-digit number. Okay. And then we're going to say that it includes a 3, but not a 1 or 2. And see if you can find the solution to this problem, this new problem here, to check your understanding. Enjoy solving that problem. Well, after doing the first option above, you might ask, is there a simpler way? Well, of course there's a simpler way, or oftentimes there is a simpler way, but sometimes we just can't find that simpler way. So if you can do the top option, that's great. But if we can go for a more clear and succinct way of doing it, then we might do this second option here. Okay. So this one involves something called the complement. So first I drew a Venn diagram on the left here. It says a 5-digit numbers without an 8 is this whole sample space right here. So this sample space is all 5-digit numbers without an 8. And that were represented with the top here, which was right here, is 8 times 9 times 9 times 9 times 9. So that was all options in the sample space. Okay. Now, what we're going to do is we're going to remove everything that's outside of the circle, because what we're actually trying to do is come up with 5-digit numbers without an 8, but it must have a 5, or at least one 5. It could be all 5s if we really wanted it to. But what we want to do is take this sample space, which is the outside, So we want to take the sample space. We want to remove the complement, and this outside here is the complement of A if the inside circle here is called A. So we're trying to remove everything on the outside. So the question would be, what is on the outside? On the outside, this space right here, the complement of A, is 5-digit numbers that do not include an 8, which we already did, or a 5. So they would have no 5 in there anywhere. So how could we do that? So the complement A, we could do this way. Well, these are 1 through 9. We already said not a 0, not an 8. And we're also trying to make it not a 5. And here we do 0 through 9, and we do not 8 and also not a 5. Again, 0 through 9, not an 8, not a 5, and we keep going here. Okay, so how many options are those? So for this first spot here, we have the option of a 1, 2, 3, 4, 6, 7, 9, which is 7 options. The next spot has 0, 1, 2, 3, 4, 6, 7, 9, which is 8 options. And the rest of these are all 8 options as well. So what you'll find out is 8 times 9 times 9 times 9 times 9 is 52,488. And 7 times 8 times 8 times 8 times 8 is 28,672. And we're trying to remove these options right here. So we're going to subtract these two from each other. So 52,488 minus 28,672, which is 23,816, which if you look at the example above, which I did eventually fill in, the answer is also 23,816. So you can see that this is a much more succinct way of going about the solution, whereas this one, the top option, well, it kind of guarantees you and you feel strong as you go through it that you've come up with every single option. This one works from the complement of A to solve it in the second option there.